Hello and welcome to C++ Weekly. In this episode, I'm going to do something that I don't really think that I thought that I was going to do. This episode is supposed to be an episode about moving from exceptions to standard expected. But we're also going to do a completely unscripted, well, not that my episodes are normally very scripted, but a completely unscripted test of the Anthropic Claude command line tool. Now, I've used enough of these agent-based AI things now at this point to know that there is some chance that this is going to do exactly what I expect it to do. Let's do a quick note. So the idea is that the agent-based AI basically creates new tasks for another AI instance, which avoids overwhelming the context window of the one that you are interacting with. Now, this particular one, called Claude, is able to do all kinds of things. I have a fresh checkout of this InFizz project. I did this episode of moving this thing from C++ pre-98 to 11 to 14 to 17 to 20 to 23. Now, the idea that I've been planning for a very long time is to do an episode where I move this thing from using exceptions to expected. We're going to see how Claude does with this. Yes, I do trust the code in here. Going ahead and let it initialize itself. It's going to analyze my code base. It's going to create its own claude.md file, which, yes, it already determined that this thing is a CMake project, and the building and dependency files are pretty much out of date, but it should pretty quickly figure out how to compile and test this thing. Notice it's even trying to find out what other AI bots have instructions in this repository. All right, so it knows two-space indentation, 120 character line limit. It has an idea that I use Pascal case for classes and camel case for members. I don't know if that's actually correct or not, that I do use constexpr, consteval, no discard, concepts, format strings. It's figured those things out. It knows how to build and test as well. I'm going to say yes. Let's see, static analysis enable with InFizz clang ID on. Yeah, so CVB check. Okay, so it's figured out these things. Let's go ahead and do this. I want it to use Ninja. I want it to, by default, do parallel builds. There we go. Yes, I'm going to go ahead and accept that. Okay, now let's get a quick... All right, I so far spent 54 cents. It wants me to restart to apply it. I don't feel like teaching it again where we are at. It does remember many things, but not everything from the previous instance. Now I've given it this very high level command. I'm saying look for all uses of expected, look for all uses of exceptions and move to expected instead. Okay, that's fair. Do include expected. Okay, so it is using an enum struct to say invalid number, invalid expression, empty token, or stack empty. Okay, sure. Those are possible errors that might happen in my infix number expression parser. Okay, so now it's changing the return types. Let's see, remove standard expected, change the return types from contained to an expected of contained or stack error. That's interesting. Definitely interesting that it's giving stack its own set of error types. And then it says return an unexpected if, yeah, okay, we'll modify stack.hpp. All right. from cars is now returning an evaluation error if it needs to. So instead of possibly throwing a not a number, it's returning, here we go, an invalid number. Yeah, go ahead. All right, so now it's showing us that we have to actually check for each operand in order that it actually returned an unexpected or whatever. It knows that it can't just rely on exceptions handling all the things. And this is part of my point about expected versus exceptions, is that we have a whole lot more manual checking to do, but, well, I guess the bot knows how to do that. Maybe. It's returning an expected avoid. I don't even know if that's valid syntax. We'll see if it is. Okay, a lot more changes in the evaluator. These look at first glance to be probably correct. Whether or not this makes sense right here, where it changed this from throw error to make error. So the problem is it's no longer carrying the context of what actually went wrong in here. So I'm going to say all right, so now it is enhanced my evaluation error to have a string that knows what the error type was and the message here. All right, go ahead and do that. Perfect. All right, now we're carrying more context. Yeah, maybe not ideal. Might have to iterate on this a few times. Yeah, here we go. This is a little bit better. Now we're getting more context saying, okay, you were trying to do a whatever, multiply or divide. Let's go ahead and let it do that. Okay, now it is back to having this smarter make error that, yeah. All right, does, no, okay, that should be good. Got there in a roundabout way. Interesting. Evaluate, evaluation error, evaluate or throw. During compile time evaluate, look at this comment here. During compile time evaluation, we can't do much better than a generic error message. So they're going to, the AI agent here is going to say, well, if it was unable to evaluate the thing as a rational number at compile time, then throw an exception, which is actually a really good choice here, because we will get a compile time error if it's unable to evaluate the thing. Yeah, so it has to re-add evaluator.hpp. So that's fascinating. Now it's using exceptions only in the case of constant evaluation. All right, so now it's changing this code to work with expected. Yeah, yes, yeah, go ahead, and you don't have to ask me again to do. Now, it always gets this wrong. It gets in the wrong, yes, you're in the wrong folder. You're in the wrong folder, Claude. You've done this many times. All right, now you get to the correct folder, you're gonna run build, you're gonna run test. Oh no, what is this? Jump to case label crosses initialization. Oh, look at that. So you have moved from a switch statement to a series of if-else blocks because you were jumping over eval result. No. Yeah, that should work. Interesting that it actually removed the default and now is only explicitly checking those cases. All right, let's see. Oh, it's Hold on now. Let's not add more test cases just yet. Let's make sure. What is happening? I should fix compilation. No, you don't. Oh, evaluate or throw. Right, you did change that. Okay. I see. Yes, go ahead and do that. It was trying to use the user-defined literals, which would have done the exact same thing, but I didn't see what it was trying to do there. And now notice it's cleaned up its own command line. It's explicitly changing to that directory each time instead of getting confused about which directory it's in. It's fascinating. Okay, all the tests built, and they all run. It's neat. All right, so now it really wants to add more test with expected. I'm going to say, I was going to change my mind for a minute. I wanted to add more things to the const expert test instead. So this is where Claude typically has been messing up for me. It's like, no, let's just remove some of these tests because we don't know how to check to see if we got the exact error that we expected or whatever. I don't like the fact that it does that. Let's go ahead and let it this time. Sure, remove part of the test. See if you can get this thing to pass yet, Claude. Okay, all the tests pass. And here's a summary here. Let's, I'm just going to look at the cost again. So we spent $1.79 using 7 minutes of API time. 20 minutes I've been hand holding it with this recording here. It sees that I am doing static require here, and it has properly put things in complex expressions, small fractions, UDL test. It's added new test cases for large numbers. Ooh, added test cases for order of operations. Ooh, I don't know if that's going to do what you want it to do, Claude. I don't know if order of operations is correct in here. I don't know. Let's see if it does. These static assertions failed, and I know from experience that this thing is going to want to comment out the failing test or somehow update them in some way. It's not helpful at all. Okay, so it has explicitly put the simplifies in here. That is probably correct. Yeah, see, now it's trying to remove these white space tests, and I don't know why. No. Fine. There's no way to move those to non-const expert because it is a const eval function. Yes. Okay, so negative number in rational number simplify. Sure, why not? Because it simplified it for you. Yeah, that makes sense. Is that correct? 5 times 4 is 20 minus 3 plus 1. That seems 20 minus 4 should be 16, yes. You just had a bug in your example, all right. Okay, $8.21 spent in approximately an hour of my time. It found and fixed, 5, 6 different bugs in the parsing, added a pretty printer to the command line, and moved from exceptions to standard expected. It added additional const expert test. We've probably, let's look at the thing here. It has its little robot here. So let's do get diff develop. Is that where we were? Yeah, this is where we were. Let's look at the test suite. So it added, well, a lot more test. These things seem to be very good at this, and if you give it strict requirements for how to use and run your test and tools for quickly iterating, then it can move through these things much faster. There's lots and lots and lots of test cases here, and you can use it for guided development of better code coverage as well for your test. Anyhow, I'm going to end things here. This was interesting. I got way further with this than I expected to in an hour. It definitely needed some hand holding, but I don't know. Hopefully you thought this was interesting. I'm going to speed up lots of things. I'll honestly say, though, at one point while it was working, I went and took a bathroom break, and I came back and it had found some of the bugs. So maybe the code quality needs help. Maybe it's not the best in places, but with really good test coverage, well, it's interesting to experiment with anyhow. AI is not just fancy autocomplete anymore, and we're talking about C++ programming. Now, thanks for watching this episode of C++ Weekly. Be sure to subscribe.